In current interaction design fields, the concept of new technology can be generally defined as any electronic device, digital service, or digital system. The changes in new technology can lead to many different outcomes when they were combined with the changing capabilities of the users. Those changes have a greater impact on the aging population than others. Stereotypes often suggest that older adults have no interest in using or learning to use new technology. Consistent with these stereotypes, studies suggested that many factors can lead to the barriers and frustration in older adults' interaction with new technology. However, proper attention to UI/UX design could eliminate much of the barriers and frustration. The world population is aging rapidly. When designing technology for older adults, it is important to consider the methods they can use to overcome the barriers and the ways to help them to keep up with the changing technologies. Prior to the dissertation research, a pilot study was conducted for the exploration of the research focus. Besides of the learning barriers, some of the findings in pilot study also highlighted that older adults can be very diverse in many dimensions. Findings from the pilot study lead to two focus areas within this dissertation research. The scope was limited from two aspects. One is older adults' demographic background. Another is the technologies that were being investigated. LFF is a new concept that were generated for this dissertation, which will be explained in detail later. In this dissertation, 3 research questions were developed in order to address the research objectives. To better understand the learning experience with new technologies among older adults, it is necessary to both learn about how learning processes build during the interaction between users and technologies, as well as which learnability-focused features will enhance older adults' learning experience. A researcher's choice of a research design is framed by the research paradigm. This dissertation research can be classified as constructivism in the 3-part continuum of research paradigms. The knowledge generated under the constructivism paradigm requires the co-created understandings of the system being studied between the researcher and the participant. For example, in the constructivism paradigm, the interaction design of new technology is viewed as a multi-component system. In order to design for a better user experience, the researcher needs to understand and consider the different aspects in the whole process by gaining perspectives from the user directly. In this dissertation research, from the perspective of older adults, their user characteristic may affect their learning process. In contrast, from the perspective of new technology, visual elements and instructions can contribute to the technology learnability. By understanding the learning process and evaluating technology learnability, design recommendations can be developed to improve the interaction design of new technology for older adults. 3 studies were designed and conducted in this dissertation research. The purpose of study 1 was to answer research question number 1 by exploring learning process and barriers among older adults with different levels of technology experience. Study 2 and Study 3 were aimed to address research question number 2. Older adults were recruited as users, and UI/UX designers were recruited as subject matter experts to evaluate the LFFs. The findings and insights combined from all 3 studies were used to answer research question number 3. Based on the literature review, many changes in physical and cognitive abilities that occur with aging, as well as users' technology experience levels, are relevant with many aspects regarding the interaction with new technology. There are many design principles that can inform the design process and benefit final design deliverables in terms of designing for older adults. For example, Jacob Nielsen's heuristic evaluation is a quick and simple user interface inspection method. Even though it was developed in 1994, all of them are still applicable and relevant. With the development in new technology, additional heuristic can be used as add-ons for the UI evaluation, such as heuristic for accessibility. There are many design guidelines to facilitate UI/UX designers in designing for older adults. Many design strategies have been applied to improve the learnability of new technology, which were sorted into 3 categories. And in this dissertation research, the second one, internal instructional features, were represented by the term LFFs. Based on the literature review, a framework regarding strategies that facilitated the user's learning process of new technology was proposed. In this figure, different strategies are positioned with the decreasing time and effort in relation to users' learning from left to right. However, it does not mean that the technology can only be learned by taking a class has low learnability. The reason for choosing a strategy highly depends upon the complexity of the technology and or the user's preferences and many other factors. Among all these strategies, some of them are design strategies that focused on self-paced learning, and some of them can be designed by UI/UX designers and applied as design elements. To better understand the experience with and barriers to learning new technologies among older adults, a focus group study was conducted to explore the technology learning processes among older adults with different levels of technology experience. A technology experience profile was used as a screening test to categorize individuals into different technology experience groups. After the score sorting from 104 TEP responses, a total of 40 older adults were recruited. Each technology experience group contained 10 participants. Thematic coding was used as data analysis method. 5 categories were identified among all segments. The frequency of the codes under each theme was calculated and sorted by the technology experience groups. There were, overall, a greater reported number of positive attitudes toward learning new technology than negative attitudes. A total of 8 themes were identified based on the different activities that technologies can support. Based on the reasons that participants mentioned when they were discussing their attitudes towards learning a specific type of new technology, 3 sub-themes were coded, including effort, memory, and time. For example, this following quote that categorized as negative attitudes were sorted into sub-theme time. 3 themes were identified under the category of learning barriers. They were abilities, product characteristics, and instructions. As for learning methods, one theme is learning alone. Another one is learning from others, which included learning from domain expert and learning from family and friends. During the focus group, when participants discussed their starting points of new technology learning process, many of them mentioned that they usually started from a wanted task. Some of them started from basic functions that were being introduced in the user manuals. Many of them commented that they would take other people's recommendations. Some participants from the proficient group mentioned that the first thing they would do was starting from system settings or system default and changing the setup into something they were familiar with. 5 categories identified in the study were synthesized in this map. They were positive and negative attitudes toward learning new technology, the starting point for the learning process, barriers to learning, learning method preferences, and the list of recommendations that some of the participants in the competent and proficient group made during the discussions. The theme listed in here were those had high frequency counts after comparing within and between the groups. A conclusion drawn from this study was that the technology experience affected many aspects of learning experience and the learning process. This finding was consistent with the study results in the literature review. To point out some of the main findings in this study, in terms of learning barriers, abilities were reported across the 4 groups. Learning barriers reported by experienced older adults can be associated with their learning method preferences. For example, problems with instructions were mostly reported by experienced older adults. Individuals were more likely to learn by themselves when they were at a relatively higher level of technology experience. Some of the suggestions that were discussed during the focus group that may potentially enhance older adults' learning experience were applied to the development of LFFs. In Study 2, 6 LFFs were evaluated by 17 older adults. LFFs were developed and applied to 2 click-through prototypes. Information regarding older adults' user characteristics were collected and were taken into account when analyzing participants' rating scores and the preferences ranking for the 6 LFFs. However, except TEP and mobile device proficiency, none of them were proved as associated with the LFF rating and ranking in this study. The 6 LFFs can be sorted into 3 categories. These are the concepts of the LFFs in category onboarding display. 2 types of onboarding display were developed. Type A onboarding display, which is the one on the left, is a self-selected onboarding. Type B onboarding display, which is the one on the right, is a quick start onboarding. These are the concepts of the LFFs in category action guidance. Type A action guidance, which is the one on the left, is warning message. Type B action guidance is pop-up text. These are the concepts of the LFFs in category customized settings. The one on the left is CA, a customized icon settings. The one on the right is CB, a customized shortcut settings. The information and the description listed in here were not provided to the older adults participants. These are just the concept overview. In this study, participants were interacted with each LFF that were applied to the prototypes directly. One prototype is an online food ordering system. This is the second prototype of a Bluetooth device pairing system. 2 prototypes were provided to each participant in random order. During the evaluation sessions, participants were asked to go through multiple tasks in the systems to try out all the LFFs separately. An iPad mini was used as a display device. Prototypes were created in Adobe XD. Post-task questionnaires were given to participants after their completion of each interaction process with the LFF. The questionnaires were used to assess LFFs by asking participants to rate the effectiveness, efficiency, complexity, and overall satisfaction. The 6 LFFs were provided to each participant randomly to avoid odor effects. This is the rating results from post-task questionnaires in PF. Some of the LFFs had different impacts on older adults' user experience between 2 prototypes. For example, the warning message got a higher average score in the rating of effectiveness in PF than in PB. In this study, to make sure that participants can understand the function that each LFF provides, it was applied many times in the prototype. However, this may lead to feature overuse. This limitation was mentioned by some of the participants during the follow-up interviews, as they initially thought those warning messages were telling them that they did something wrong. And it turned out to be the confirmation or the feedback for participants' previous action. Among all 6 LFFs, Quick Start Onboarding got the highest average of the ratings in 2 prototypes. Warning Message got the highest preferences ranking score average. Quick Start Onboarding got the highest frequency count of the most preferred. And during the follow-up interview, when asking participants to recommend one LFF to their family friends, 6 participants said they would recommend the customized icon. To be noticed, custom icon got the lowest preferences ranking score average. In this study, participants who recommended CA all had relatively high scores in technology experience profile as well as in mobile device proficiency. As they were recommending CA to other people, they were thinking of those who were not experienced in using or learning technology, and they were commenting that the feature CA can be extended to the product that are not heavily rely on digital interfaces but are more associated with physical buttons. Similar to Study 2, the 6 LFFs were being evaluated in Study 3, but in this study, a total of 15 design professionals were recruited as evaluators for the cognitive walkthrough sessions. Based on the results from the self-reported screening test, most of the participants are familiar with the design principles and design guidelines about designing for older adults, and all participants have experience in using cognitive walkthrough. During the evaluating session, as evaluator walk through the list of LFFs, they need to wear a hat in a metaphoric fashion and walk through the concept of each LFF from the perspective of the older adult users. 4 older adult users' persona were created based on technology experience level as well as stage of use, and they were provided to the evaluators in a random order. To evaluate the 6 LFFs, evaluators were presented with 2 scenarios: ordering food and pairing a headphone. Instead of presenting the LFFs in the interfaces of the prototypes like the procedure mentioned in Study 2, in this study, LFFs were presented to the evaluators in a written format. Even though UI/UX designers rarely work with text-based content, but this arrangement was designed purposefully to eliminate the distraction created by the visual components in the features. The screenshots of the user interface of all the steps in the 2 scenarios were provided to participants. During the cognitive walkthrough, participants were asked to evaluate the LFFs considering the accessibility, ease of use, as well as usefulness. The evaluation results were listed in this chart. The persona figures show up in the chart represented that 12 out of 15 participants agreed that the LFF could fulfill the criteria. For example, customized icon and customized shortcut were evaluated as not accessible and not easy to use by first-time users. Also, evaluators commented that the process of creating the customizations might be hard for returning novice users. Based on the step-by-step evaluation and the comments made during the discussion by the evaluators, the results from this study were summarized in a quadrant chart. LFFs regarding customize were considered to be beyond the capability of first-time novice user. However, from the previous study, novice older adults encountered most of their learning barriers when they were recognizing icons or remembering operating procedures of the technology. Therefore, the timings of introducing the concept of customized settings may affect novice older adults' learning experience. The 3 studies reported in this dissertation were interconnected. These are the mixed findings from the 3 studies regarding the pros and cons of each LFF. Even though the LFFs were not evaluated in the focus group study, design concepts of the 6 LFFs were generated based on the discussion in Study 1. For some of the LFFs, there were overlapping results among the 3 studies. However, some of the LFFs were having inconsistent responses across studies. Based on the findings from the 3 studies, recommendations for designing for older adults that tailor to their technology experience levels are as follows. For novice users, initiate task-oriented features, so they won't be scared by the dreadful instructions and information and increase their open box fear. But at the same time, the LFF in the technology need to be informative enough for the novices to avoid any accidental dismissal due to the mistakes and/or slips. And for proficient users, an experience-oriented learning process is recommended. Design features that encourage self-paced learning were promoted, and it is recommended to have features which let users transfer their experience from one part of a technology to another. For more information about the data and the supporting materials of the studies, please see the links in the info box down below. Thanks for watching.